Students, hello students. In previous lecture, we discussed about the different number systems: decimal, binary, octal, hexadecimal. Decimal number system is base 10 number system, which consists of 10 symbols 0 to 9. Binary number system consists of 2 symbols, and this is called as base 2 number system. 0 and 1, these 2 symbols are used to represent the numbers. Octal number system consists of 8 symbols: 0, 1, 2, 3, 4, 5, 6 and 7, and therefore it is called as a base 8 number system. Hexadecimal number system consists of 16 symbols: 0 to 9, 10 symbols, and A, B, C, D, E, F, these are the 6 symbols. So 16 symbols are used, hence it is called as a base 16 or radix 16 number system. Also, we discuss double method, which is used to convert the decimal number into its equivalent binary number, and also one of the conversion method which is used for binary to decimal conversion. In this session, we are going to discuss another conversion methods like decimal to hexadecimal, decimal to octal, hexadecimal to decimal, decimal to hexadecimal, etc. So first we are going to discuss how to convert one of the octal number into its equivalent decimal number. Octal means base 8 number system, and whose weight defined by the position of the symbol. So it is one of the positional number system. So the decimal equivalent of octal number is nothing but addition of the weights of each digit. Means, for example, we have to convert octal number 6327.4051. That is one of the octal number. So this is a valid octal number because 0 to 7 symbols are used, and this is a base 8 number system. So what we have to do? We have to note down the appropriate weight. The weight of this 6 is nothing but 8 raised to t. Weight of this 3 is nothing but 8 raised to 2. Weight of this 2 is nothing but 8 raised to 1. And weight of this 7 is 8 raised to 0. Similarly, 4 has weight of 8 raised to minus 1. 0 has 8 raised to minus 2. 5 is nothing but 8. 5 into 8 raised to minus 3. And this is 1 8 raised to minus 4. So accordingly, we have to note down the weights of each digit, and we have to add these bits. We have to add this bit, and the equivalent result is nothing but the equivalent decimal number. So the decimal equivalent of this is 3287.510098. So this is one of the method which is used to convert the octal number into its equivalent decimal number. Means we have to note down the weight of each digit. Weight of each digit means 6, 3, 2, 7. Weight of this is 8 raised to 0, means 7 into 8 raised to 0. This is 2 into 8 raised to 1, 3 into 8 raised to 2, and 6 into 8 raised to 3. Likewise, and if we have to add these weights, we will get the equivalent decimal number. Similarly, one of the example, we want to convert the hexadecimal into decimal. No doubt we know that hexadecimal contains 16 symbols: 0 to 9 and A to F. So suppose this is one of the number, that is 3A.2F. This fraction point is called as a hexadecimal point, and now we have to convert this hexadecimal number into decimal number. Similar to the binary to decimal and octal to decimal, we have to note down the weight of each digit, and we have to add this. Means, for example, 3A. 3 has the weight 3A it has the 16 raised to 0 and it has the weight of 16 raised to 1. 16 raised to 0 means 1 and this A means 10. So A is nothing but 10, B is nothing but 11, C is nothing but 12, D is nothing but 13. Because in case of the hexadecimal number system, we write 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. After that, we represent 10 as A, 11 as B, 12 as C, 13 as D, 14 as E and 15 as F. So A is nothing but 10, B is nothing but 11, C is nothing but 12, D is nothing but 13. Likewise, F is nothing but 15. So we have to note down the weight of each digit. So accordingly here 3A.2F. First for the integer part we will see. For the integer 3A.16, 16 raised to 0, 10 into 16 raised to 0 and 3 into 16 raised to 1 because A is nothing but 10. And for this fraction part 2F, 2 into 16 raised to minus 1 and F is nothing but 15, therefore 15 into 16 raised to minus 2. If we add the weight of this, because 16 raised to minus 2 means 1 upon 16 square means 15 upon 16 square, 2 upon 16, 10, 16 raised to 0 means 1 and means it will be 10, 16 raised to 1 means 16 into 3, so it will become 48. So 48 plus 10 plus 2 upon 16 plus 15 upon 16 square is nothing but 58.1836. That is our equivalent decimal number. In this way we can convert hexadecimal to decimal. So remember that when we are going to convert any base number into the decimal convert, we have to add the weight of these digits. Means for hexadecimal to decimal, take the weight of the numbers in the power of 16 raised to 0, 16 raised to 1, etc. When we want to convert octal to decimal, take the power of 8 raised to 0, 8 raised to 1, 8 raised to 2, etc. In case of the binary to decimal, take the weights 2 raised to 0, 2 raised to 1, 2 raised to 3, etc. And add these weights, we will get the equivalent decimal number. So means before that we discussed that how to convert the equivalent binary number. So that binary number 10.1011 is nothing but equivalent 2.6878. Means weight of this will be 0 into 2 raised to 0, 1 into 2 raised to 1, 1 into 2 raised to minus 1, 0 into 2 raised to minus 2 likewise, and we will get the equivalent decimal number. Means we know that any base can be converted into its equivalent decimal number by adding the weights of each digit. So now we are going to convert reverse. How to convert the decimal number into hexadecimal number. Before that we discussed that decimal number can be converted into binary by dividing integer part successively by 2 and keeping the track of reminders. And fraction part is multiplied by 2 and keeping the track of integers. Similar to this hex table method is used. In case of the hex table method, if we want to convert the decimal number to hexadecimal number, for the integer part, we have to divide the integer by 16 and keeping the track of reminders, similar to the decimal to binary conversion. And for the fraction part, we have to multiply the fraction part by 16 and keep the track of integers. We will see with one of the example. Suppose this is one of the example, 95.5. This is one of the decimal number and we have to convert it into the hexadecimal number. So for the integer part, we have to successively divide it by 16 and keep the track of integers. So now we will divide 95 by 16. 16 divided by 5, we will get 80 and remainder will be 15. So 15 is represented by F because decimal 15 is nothing but hexadecimal F. So we will represent it as a hexadecimal symbol F. So again there is 5. We have to divide 5 by 16. So it is not divided, hence note down here 0 and 5 is carry forwarded like this. So and the result will be read in upward direction. So in this way we can convert any decimal number into its equivalent hexadecimal number. So now we know that by dividing successively the integer part and keeping the track of reminders, we will get the equivalent hexadecimal number. So 95 decimal integer part will be 5f, and now read this in upward direction. For the fraction part, 0.5 successfully multiply by 16 this fraction, we will get some integer, and that integer will be noted down as a result. So 0.5 into 16 is equal to 8.0, and the integer will be 8. Suppose the number is different, 0.6, that is your equivalent decimal number, then what we have to do? So in this case the 16, 0.6, that is suppose decimal number, we have to multiply it by 16, that will be 9.6, and the integer part will be 9. Again we have to multiply it by 0.6 into 16, so again result will be 9.6. Again we have to multiply by 9.6, so result will be 999 in downward direction. So in this way we can convert integer as well as fraction. Means for hexadecimal method, integer part is divided by successfully by 16 and keep the track of integers and read the remainder in upward direction. And for the fraction part, we have to multiply the fraction by 16 and keep the track of integers, and integers are noted down in downward direction. So how to convert the decimal number into octal number? We previously discussed that for the decimal to binary, we divide the integer by 2 and multiply by fraction by 2. For the conversion of decimal to hexadecimal, we divide the integer by 16 and multiply the fraction by 16. Similar to this, decimal to octal conversion is carried out. Means for the integer, we have to successfully divide the integer part by 8 and keep the track of reminders. And for the fraction part, we have to successively multiply the fraction part and keep the track of integers. We will discuss with the help of example. Suppose this is one of the example, 247.6875, that is one of the decimal number, and we have to convert it into the octal number. Then for the integer part, we have to successfully divide by 8 and keep the track of reminders. So how this is carried out? 247 divided by 8. What we will get? The remainder will be 7. This will be the remainder. Remainder will be 7. Again we have to divide this 30 by 8. Then what will be the result? The remainder will be 6, and we will get the remainder 6, and this will be the, again 3 is divided by 8, it is not possible, so 3 is noted down as it is here. So we will get 3 and there will be the 0. So we will note here 0. So the result is read in upward direction, means 367, that is the equivalent number. So 367, that is equivalent octal number for the decimal 247. And the base will be the 8, means 247 base 10 is equal to 367 base 8. So for the fraction part, we have to successively multiply this fraction by 8 and keep the track of integers. So 0.6875 into 8, 5.555, that is equal to 5.5. So 5 is MSB bit. Similarly, this 5.5 is 0.5 is divided by 8, multiplied by 8, we will get 4.0. So result will be 54, and that result is noted down in downward direction. So read the upward direction. That result will be read in downward direction. This is like this, because the result goes on increasing if there is no zero. So in this way, these are the simple methods which can be used to convert one of the base into another base. So we will get the different exercise on this topic. Samples are here. For example, convert the following decimal number into octal number and hexadecimal number. Try to solve these examples, and if any queries, send one of the message. So these are some examples for the homework. So try to solve this. Thank you for this session. In the next session, we will discuss the further part of this topic. So you will get all the answers and detailed notes. So one more thing is there will be the question in the examination. Explain the double method with suitable example. So you have to write the steps how to convert the decimal number into its equivalent hexadecimal number with one of the suitable example. Thank you.